welcome to Two Projects. In this video, we are going to explain the project Fusion-based CNN approach for diabetic retinopathy detection from fundus images. Before diving into the execution, let me give you an overview of the project. So first we'll know what is diabetic retinopathy. So diabetic retinopathy is a condition affecting the eyes of individuals with diabetes. It results from damage to the blood vessels in the retina due to prolonged high blood sugar levels, potentially leading to vision impairment and blindness if not addressed promptly. So, this project focuses on developing an automated system using fusion based convolutional neural network approaches to detect diabetic retinopathy from fundus images. So, this system categorizes images into five severity levels that are mild, moderate, no DR. DR means diabetic retinopathy, proliferative DR, and severe DR. These are the five severity levels. So, now we'll see the traditional methods. So, traditional methods of doing this, such as manual examination by eye specialists, are slow and prone to subjectivity. Subjectivity means interpretation variations among specialists. And these methods require specialized equipment and skilled personnel and often identify problems only after symptoms appear. Early detection of this disease is very important for timely treatment, preventing vision loss, and improving patients' quality of life. So, automated screening using deep learning algorithms speeds up the process, ensures consistent results, and reduces costs. This allows eye specialists to focus on severe cases, enhances diagnosis, and identifies issues before they become serious, benefiting both patients and healthcare systems. So, deep learning techniques, notably CNNs that are convolutional neural networks, have emerged as promising tools for automating the detection of diabetic retinopathy from fundus images. So, CNN can examine numerous eye images and identify potential issues like diabetic retinopathy. So, by studying many examples of different eye conditions, it learns to recognize specific signs of DR accurately. This system's strength lies in its ability to detect problems in new images it hasn't encountered before, aiding doctors in identifying issues early, providing timely treatment, and ultimately improving patients' outcomes. So, we will be using deep learning techniques for predicting diabetic retinopathy. Now, we'll see the workflow. So, the dataset used in the project contains a collection of fundus images of varying quality and representing different stages of diabetic retinopathy. So, the first step in the workflow is performing exploratory data analysis. So, exploring the dataset is very important because it helps us understand the distribution of different classes of images and the characteristics of these images. So, this exploration provides details, insights into the diversity and complexity of the dataset, guiding our pre processing steps and model development. Next comes pre processing. So, pre processing the dataset involves preparing the images for analysis by the deep learning models. So, we utilize techniques such as data augmentation to enhance the quality and diversity of the dataset. Data augmentation involves applying transformations to the images such as resizing, sharing, zooming, flipping, reshaping, etc. So these techniques help increase the variability of the dataset, improving the robustness and generalization capabilities of our models. So after pre-processing, we will split our dataset into two sets, train and validation sets. Train set is for training the deep learning models and validation set is for evaluating their performance. So we will be employing various pre-trained CNN architectures including ResNet 50 inception, V3 exception, Dianet. So We will train these models and will evaluate the performance of these models using different performance metrics like accuracy, precision, recall, and F1 score. And we will select the best performing model among them for diabetic retinopathy detection. So, this is what happens in this project. Overall, the primary aim of the project is to develop a system leveraging deep learning and advanced image processing techniques. By enhancing early detection and intervention for diabetic patients, our system ultimately aims to improve their quality of life while reducing the strain on healthcare systems by automating and streamlining the screening process. Now we'll look at the software and hardware requirements to execute this project. Hardware requirements are operating system of Windows, processor of i5 and above, RAM of 8 GB and above, and hard disk of 25 GB and above. Software requirements are application needed is Anaconda, primary language required is Python, front-end framework needed is Flask, backend framework required is Jupyter Notebook, database needed is SQLite 3, and front-end technologies required are HTML, CSS, JavaScript, and Bootstrap 4. Now we look at the algorithms built. So in the base paper, author has proposed Dianet. So it is an ensemble model combining ResNet and Inception v3 for feature extraction, and CNN model is used for analysis. So this proposed model was compared with Inception v3 and ResNet 50. So Dianet has outperformed the other models in the base paper. Now for improved performance, we are proposing exception model in this project. So we will be building all these models, the models proposed by the author and the model which we are proposing, and we'll compare their performance using different performance metrics like accuracy, precision, recall, and F1 score, and we'll select the best performing one among them for diabetic retinopathy detection. Now we will understand about the algorithm which we have proposed, that is exception. So, exception is a deep learning technique. It is known for being good at understanding images. So, it does this by breaking down the process of looking at images into two main steps. First, it looks at different parts of the image separately. This is called depth-wise convolution. Then it combines these parts to understand how they relate to each other. This is called point-wise convolution. So this helps exception to understand images better and pick up on important details. One of its strengths is that it is really efficient at doing this, which is important when we are dealing with lots of images. Plus, it is great at figuring out what features in the images are important for making classifications. Another important thing about exception is that it can learn from other datasets before being used for a specific task. This is called transfer learning. So this makes it super adaptable and useful for classifying fundus images. So after comparing all these models, we have observed that exception model has outperformed all other models in all the performance metrics. So we have deployed exception model into Flask web application. Now we will be executing the project using Flask web application. So before execution, first we need to open the code folder which contains the project source code files. So this is the code folder and these are the contents I have in the code folder. I'm opening data folder. We can see I have two subfolders. I'm opening train folder. So in the data set, I have 5 different classes. So these are different severity levels: mild DR, moderate DR, no DR, proliferative DR, and severe. So DR means diabetic retinopathy. So I have respective images in these folders. I'm opening mild folder. So we can see these are different fundus images indicative of mild DR. Similarly, these are different fundus images indicative of moderate DR. These are different fundus images indicating proliferative DR. So I have respective images in other folders also. So on these images from all these folders, we will train the deep learning models. Similarly, I have 5 different classes of images in test folder also. So on these images, we will evaluate the model's performance. So this is about the dataset, and this is sample folder in which I have images again. On these images, we will make the detections. So these are the test cases we have. This is static folder. This folder consists of files related to CSS, JavaScript, and Bootstrap. This is templates folder. This folder contains all the HTML pages used in the project. It typically includes files like index.html, about.html, etc., which represent different pages of the website. This is app.py file. This .py file contains the information related to front-end logic. It includes code written in Python that handles server-side operations such as processing user requests, interacting with the database, and generating dynamic content to be rendered in the HTML templates. And these are model files which contain algorithm information. These files will be loaded into the project code during runtime to utilize the trained models. This is Notebook Jupyter source file which contains a combination of code, graphs, and outputs all in one place. So Jupyter source file allows users to write and execute code in individual cells, making it a popular choice for data science. And this is signup.db file. This file is the database file used to store user information. It stores information like signup details. So now copy the path of the code folder from the address bar of the file explorer. I'm copying it. Open Anaconda prompt. Use the command cd followed by a space and paste the copied path and hit the enter button. So this command is used to change the current directory to the code folder's path. Now compile the app.py file using the command python space app.py. I'm typing python space app.py and hit the enter button. So this command will execute the Python script and perform a runtime check for any syntax errors or logical errors. After running the app.py file, the Flask framework will host the application locally at the default address, localhost, and port unless configured differently. Now copy the local link provided by the framework. I'm copying it and paste it into any web browser. I usually prefer Chrome. After pasting it, hit the enter button. So the home page of the project has been displayed in the browser. This is the front end built using Flask framework. So this is the front end, and here we can see a sign up link. Click on it. So if we are new users, we have to register ourselves first. Fill in all these details and click on register button to sign up. And if we already have an account, we can directly log in by clicking on this link. So as I'm already a member, I'm clicking on this link. Here we have to give our credentials, username and password. I'm giving mine and click on login button. So it has redirected us to the classification page. So now we have to upload any Fundus image and the application will classify if the person has the diabetic retinopathy and the severity level of the disease. Click on choose file button. So from sample images folder, so these are different classes I have. I'll upload any image from mild folder. So these are different test cases I have. I'm uploading this image. The image has been loaded. Now click on upload button. So this is the uploaded Fundus image and here we can see the classification that is mild DR. So the application has correctly classified it as mild DR and here we can see a small description about the disease that it is the early stage of the disease in which symptoms will be mild or non-existent. We'll try again giving another image. Click on try again button. Click on choose file. So this time we'll try with moderate image. I'm uploading this one. This is the uploaded Fundus image and here we can see the prediction that is moderate. And we can see the description here. Click on try again. Click on choose file. We'll try with another image. I'm selecting this image. Click on open. The image has been loaded. Now click on upload button. This is the uploaded fundus image, and here we can see the classification as moderate again, and we can see the description about the disease. Click on try again button. We'll try with some more test cases. Click on choose file button. This time we'll try with no DR images. So I'm uploading this image. Click on open. The image has been loaded. Click on upload button. This is the uploaded image, and here we can see this person do not have diabetic retinopathy. It is no DR. The application has correctly classified it as no DR. Click on choose file. We'll upload from proliferative DR folder. I'm uploading this image. This is the uploaded fundus image, and here we can see the correct classification, that is proliferative DR. And here we can see the description. Sorry, I've clicked on try again button. Click on choose file. We'll select this image this time. Click on open. Click on upload. This is the uploaded fundus image, and here we can see the classification, that is proliferative DR, and we can see the description, that is it is the advanced stage where abnormal new blood vessels grow on the surface of the retina. Click on try again. Click on choose file. This time we'll try with severe image. I'm uploading this one. This is the uploaded image, and here we can see the classification, that is severe DR. And we can see the small description about severe DR, that it is an eye condition that can cause vision loss and blindness in people who have diabetes. Similarly, we can upload any image of fundus and can get the classification. Click on choose file, select the image. I'm selecting this image. Click on open and click on upload. This is the uploaded image, and here we can see the classification, that is severe DR again. And we can also see the description of the disease. We'll try with one more. Click on choose file. We'll upload mild one. I'm uploading this image. This is the uploaded image, and here we can see the classification, that is mild DR. Now we look at the graphs. Click on graphs link here. Here we can view all the visualizations made. So this is accuracy and loss graph of exception model. I'm zooming it. So in this graph on x-axis I have epochs, and on y-axis for this graph I have loss, and for this graph I have accuracy. So we can see for every increasing epoch, loss is decreasing, and for every increasing epoch, accuracy is increasing. That means the exception model is doing well. And this is accuracy scores comparison graph, a horizontal bar graph. In this graph on x-axis I have accuracy scores, and on y-axis I have algorithm names. So accuracy is a measure of how well a model correctly predicts outcomes. It represents the proportion of correctly classified instances among all instances evaluated. Similarly, this is precision scores comparison graph. Precision is a measure of the correctness of positive predictions made by a classifier. This is recall scores comparison graph. Recall is a measure of the classifier's ability to correctly identify all relevant instances from a dataset. And this is F1 score's comparison graph. F1 score combines precision and recall into a single value. It provides a balance between precision and recall, taking into account both false positives and false negatives. So, from all these graphs, we can see that exception model has outperformed all other models in all the performance metrics. So, these are the graphs plotted. Now, click on sign out. So, by leveraging deep learning and advanced image processing techniques, we have developed an approach for diabetic retinopathy detection. So, by enhancing early detection, it improves patient outcomes and reduces the burden on healthcare systems through efficient automation of the screening process.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.